In this video, we are going to be graphing a hyperbola. A hyperbola is a conic section formed by intersecting a cone with a plane at an angle that cuts through both halves of the cone. This creates two mirrored unbound curves. It is defined as the set of points where the difference in distances to two fixed points, which are known as the foci, is a constant. Some core parts of the hyperbola is the center, the vertices, and the foci, and the asymptotes. The center is the midpoint between the two vertices and the intersection of the axes. For vertices, they are the closest points on each of the two symmetric branches. Foci are the two fixed points located inside each curve used in the definition of the hyperbola. And asymptotes are two diagonal lines passed through the center that the hyperbola gets closer to but never touches as it stretches towards infinity. Okay, now that we have that, let's start by doing the first question. But first, let's look at why a hyperbola is considered a conic section. As you can see, I have two cones, right? And I have a plane that intersects. Okay? So that plane intersects there. And what you get when you cut them is here. So as you can see, those are the two hyperbolas that form. Okay, now that we understand why it is considered a conic section, let's move on to our first question. Okay, for our first question, let's first understand what hyperbola it is. So, there are two types of hyperbolas. There is a standard horizontal hyperbola and a standard vertical hyperbola. So to understand whether your hyperbola is a horizontal hyperbola or a vertical hyperbola, you have to look what term it starts with. So, if your term starts with x, or the beginning of the equation starts with x, then that means it is a horizontal hyperbola, and it's parallel to the x-axis. And if the first term contains y, then that would mean that your hyperbola is a vertical hyperbola and goes along the y-axis. So let's look at this. As you can see, our first term is x. So what that means is that this is a horizontal hyperbola. A horizontal hyperbola opens left and right, and its standard equation is x minus h squared over a squared minus y minus k squared over b squared, which equals 1. Okay, now let's define what the center A, B, and C equal. Okay, so the center is always going to be at h, comma, k, and A are just these values, and C is the focal length. And so for a hyperbola, it is c squared equals a squared plus b squared. And now your math teacher, for the values of a and b, they might say that for a horizontal hyperbola, the value of b is irrelevant, but I'm going to show you how later it really isn't. Okay? So yeah, let's start filling these out. So for the center, let's look at our equation. We have x minus 2, so this is 2 comma, and then plus 1, so this is negative 1. Okay, we have that, so let's plot that. Now let's find the value of a and b. So the square root of 9 is 3, and the square root of 25 is 5. And c squared equals a squared plus b squared is 3 squared plus 5 squared equals root 34. Okay, now we have enough information to start to finally graph. Let's do this. Okay, so the value of a in a horizontal hyperbola is the distance from the vertices to the center. So what that basically means is our point is going to be here. This is going to be our vertice. Right, we have that. Okay, and now this is where the value of b might come in handy. So basically what we want to do is construct a rectangle. So what that means is that, let's count here. So 1, 2, 3, 4, 5. So let's just mark it here. That's 5. And then 2, 3. So this is 5, right? So what we want to do is, remember, create the rectangle. Here. And let's erase our original points. So here, erase that, and erase this. Okay, now let's convert this to dotted. Okay, now that we have that, we can construct the diagonal asymptotes, right? So let's do that. So a straight line. Okay, wait, we encountered an error because this is 1 unit above here. Yeah, sorry about that. And now we draw the other line. Okay, and now that we have that, we can start to draw our actual hyperbola. Okay. So I've never actually drawn a hyperbola before. So this might work. And that is our one side of the hyperbola. Time for the other. Yeah, so this method of doing one side I feel like there's too much of a space here. Okay, that's one side, and now for the other. I'll be trying to go a little bit more faster this time. And that is our hyperbola. Okay, now we obviously have to draw on our foci, but this is pretty easy since this is based on the center, so it's -2 plus or minus root 34, comma, -1. And root 34 equals, in decimal format, approximately 5.83. So that means our foci should be around here. Okay, and those are the foci. Now it's time for the transverse and the conjugate axis. So the transverse axis for this is 3 plus 3 is 6. And 5 plus 5 is 10. Okay, and now for the harder part. So now we have to find the domain. To find the domain, we have to look at the rectangle we made earlier. Okay, so we see that it ends at -1 and here. Right, so it's going to be at -infinity, -1 bracket, no bracket actually, since it's asymptote there. Actually, wait, it is bracket since there's a vertices there. Union, and then it starts at 5, bracket 5, comma, infinity. And then this is just -infinity to infinity. Okay. And I forgot to explain what the transverse axis and conjugate axis is. So the transverse axis is basically the line that connects the two vertices, and the conjugated axis is just this line segment. Okay, time for the next question. So for this question, since it starts with y, it is a vertical. It's a vertical hyperbola. So that means instead of h of k, it's k of h. So negative. Well, it's still technically h of k. So it's -1, comma, -3. And then a is 1. And then the square root of 36 is 6. Then 36 plus 1 is the root of 37. So now let's graph. And now there's a distance of 1. And now it's time to make our rectangle. So there's a distance of 6 units. Okay, and now time for the diagonal asymptotes. And those are the diagonal asymptotes. Now we have to draw an hyperbola. So that almost looks like a straight line. but it isn't. And that's the bottom side. Now time for the top side. And maybe I think I can just duplicate this. Yeah, this is really hard to duplicate. And that is our hyperbola. And time to find the foci. So since this is a vertical hyperbola, we're going to base our foci off of the y. So -1, -3 plus or minus root 37. So converting root 37 to decimal form, that's around 6.8. So 3, another 3, so 3, so 3, 1, 2, 3, 4, 5, 6. And those are our two foci. And the length of the transverse axis, so 1 plus, not 1 plus 1. Oh yeah, it is 1 plus 1. So 1 plus 1 equals 2. The conjugated axis is 6 plus 6 equals 12. And then since this is vertical, this is just negative infinity to positive infinity. And the range, there's only a 2-unit gap, so it's just here. And that is it for this video. I'll be doing these two hyperbolas in the next one. Thank you for watching.